አመሰግናለሁ። ስሜ ለሚ ኃይሌ አይዲ ነምበር 0027 ነው። ፕሮጀክታችን ኤምኤምፒቲ ሶላር ቻርጅ ኮንትሮለር ነው። እዚህ ጋር ፒቪ ቮልቴጅ አለ ማነው ፒቪ ፓናል አለን ወይ ደግሞ ፖቴንሺዮ ቮልቴጅ ፓናል አለን። እዚህ ጋር ሶላር ኤነርጂን እንዴት አድርገን ወደ ኤሌክትሪካል ኤነርጂ ቀይረን እንደምንጠቀም ነው። እዚህ ጋር አንስተብል የሆነ ፓወር አለን ወደ ስተብል የሆነ ፓወር አድርገን እንድንጠቀም ነው። እዚህ ጋር ያለን ሬሲስተር አለን። እዚህ ጋር ጥቅሙ ሊሚት ለማድረግ ይጠቅመናል። ሬሲስተር ሲሪየስሊ ኮኔክትድ ሆነዋል ከአሚትር ጋር እንዲሁም ደግሞ ከቮልትሜትር ጋር ፓራለል ኮኔክትድ ሆነዋል። እነኚህ አሚትሩ ካረንት ሜጀር ለማድረግ እንጠቀምበታለን። ቮልቴጅን እንዲሁም ቮልቴጅን ሜጀር ለማድረግ ይጠቅመናል። እዚህ ጋር ሲን አለን ሪፕላችን ሪዲዩስ ለማድረግ እነኚህ ቦስት ሰርኪዩት አለ። እዚህ ጋር ደግሞ ዳውዳችን ደግሞ የኤሌክትሪክ ፍሰትን ወይ ደግሞ ፍሎ ኦፍ ኤሌክትሪክ ካረንትን በአንድ አቅጣጫ ብቻ እንዲሄድልን የሚጠቅመን ነው። እዚህ ጋር ሲአውታችን ደግሞ አውትፑታችን ስሙዝ ለማድረግ እንጠቀማለን። እዚህ ጋር ባትሪ አለን። እነኚህ እዚህ ውስጥ የሚጠቅሙን ናቸው። እዚህ ጋር ሴንሰር አለን። ሴንሰራችን መጥቶ እዚህ ጋር ከአርዲኖ ጋር ሆኖ ሴንስ አድርጎ ኤሌክትሪካል ኤነርጂን ወደ እንትን ቀይሮን የሚያሳየን ነው። እዚህ ጋር ያለው ባትሪ አለን። ባትሪያችን ከአርዲኖ ጋር ኮኔክት ተደርጎ እዚህ ጋር ዲስፕሌይ ላይ እዚህ ጋር ዲስፕሌይ የሚያደርግልን ቮልቴጅን ፓወርን እንዲሁም ኢፊሸንሲን እነኚህን ዲስፕሌይ ያደርግልናል። አጠቃላይ እነኚህን ይመስላሉ። የቀረ ደግሞ ጥላሁን ይቀጥላል። ይሄን ይመስላል እና አመሰግናለሁ።
Hello everyone, my name is Tilahun Shatu. I will start from my friend left off. Our project title is MPPT Solar Charge Controller, and I will start circuit diagram. We have PV panel, photovoltaic panel now. It used to convert sunlight to electrical energy, and we have voltage sensor, current sensor, and a resistor, and we connect ammeter seriously and voltmeter parallel. Ammeter used to measure current and voltmeter used to measure voltage, and we have this boost converter. Cin used to reduce ripple of input voltage, and inductor it used to release and store the voltage, and we have a MOSFET, and we have a diode. It used to one direction flow of current, and we have Cout used to smooth output voltage and connect with load. ሎዱን እዚህ ጋር ደግሞ በሶላር ቻርጅ በባትሪ ቀይረነዋል። ባትሪውን እዚህ ጋር አጀስት ማድረግ እንችላለን። ሬዚስተሩን በመጨመር እና በመቀነስ እዚህ ጋር አውትፑቱ ላይ ያለውን ኮንትሮል ማድረግ እንችላለን። እዚህ ጋር አርዲኖ አለን። አርዲኖ ከኤልሲዲ ዲስፕሌዩ ጋር ተገናኝቷል። ኤልሲዲ ዲስፕሌይ it used to display PV voltage, PV current, duty cycle, and power, and we have current sensor connected at this circuit, and voltage sensor connected with this ሰርኪት ኤንድ ቨርቹዋል ሲሪያል ፖርቱን እዚህ ጋር አገናኝተነዋል ከዲስፕሌዩ ጋር እንዲገናኝልን ወይም አውትፑቱን ዲጂታሊ ኮኔክት አድርገን ለማየት ይጠቅመናል ማለት ነው። ጨርሻለሁ። ቴንክስ ኤ ሎት።
Okay. My name is Milion. I want to continue our presentation. Uh, Most of the part from this circuit from this circuit they said a lot. So I want to revise somehow and I want to go some through a code. So let me start. So when I will start, this is our topic was mainly focused on maximum power point tracking solar charger controller. So since how it I want to explain how it can do this. So this part was first it was our panel. So this panel has a lot of uh, cells. So those cells are collect a lot of light energy. So maybe just those light energy was fluctuating due to those fluctuation. We need to use this circuit. That means this is our boost circuit. In case something when the light radiation was weak, maybe it was boosting our circuit. ስለዚህ ሰርኪታችን ምን ያደርግልናል ማለት ነው? ቡስት ያደርግልናል ማለት ነው። ስለዚህ ያለው ፕሮግራማችን ይሄ ነው። ሰርኪታችን ይሄ ነው። እዚህ ጋር ባትሪያችን አለ። ይሄ ከረንት ሴንሰራችን እቺ ለብቻዋ ሴንሰር ነች። ፊድባክ አለው ሴንሰራችን። ቮልቴጅ ዲቫይደር አለ። ኮሚኒኬሽን ፖርታችን አለ። አናሎግ አናላይዛችን አለ። እቺኛዋ ፓርት ደግሞ ምንድነች? ከማይክሮ ኮንትሮለሯ ሰርኪታችን ላይ ወይ ደግሞ ቡስት ኮንቨርተራችን ላይ ሞስፌት ስለተጠቀም ሞስፌት እንደ ስዊች ነው። ያችን ስዊች ትሪገር ማድረግ ስለሚያስፈልግ ምንድነው የምናደርገው? ከሞስፌታችን ላይ እዚህ ትሪገር እናደርጋታለን ማለት ነው። ስለዚህ ኮዳችን በፕሮቶስ ኮዳችን እንዴት እንደሰራነው ኤክስፕሌን ላድርገው። ኮዳችንን የጀመርነው ላይብረሪውን ኤክስፕሌን በማድረግ ነው። ከዛ ምንድን ያደረግነው የአርዲናችን ፖርቶችን ዲክሌር ማድረግ ነው የጀመርነው። መጀመሪያ ፓርታችን ዲክላሬሽን ነው የኮዳችን ማለት ነው። እዚህ ጋር እንደምናየው ምንድነው ያደረግነው? ፒን 13 ለኤልሲዲ ይሄ የመጀመሪያ ፓርት የኤልሲዲው ወይ ደግሞ የዲስፕሌያችን ኮድ ነው ማለት ነው። እሱን እንዴት ነው ያደረግነው? ሶስት እንትን አለው አራት ስቴቶች አሉ። ስለዚህ የተጠቀምናቸው ወደ ኦልሞስት ወደ 6 ምናምን ፒን ተጠቅመናል። ከስድስቱ እዚህ ጋር ሪሴት አለ ኢኔብል አለ። አራት የተለያዩ ምኖች አለ ማለት ነው። ዲስፕሌይ እዛ ጋር የሚሆነው ዲስፕሌይ አራት ዲስፕሌይ ኮዶቻችን አሉ። እነዚህ ፒኖች የቱ ጋር ነው የተገናኙት? እዚህ ጋር ሮታታችን ላይ ያው እዚህ ጋር እንደዚህ አገናኝተናቸዋል ማለት ነው። እነዚህ ለኤልሲዲ ለዲስፕሌያችን ብቻ ያገናኘነው ዲክሌር ያደረግናቸው ኮዶቻችን ናቸው ማለት ነው። እዚህ ጋርም እንደዛው የተለያዩ እንትኖች አገናኝተናል። ሴንሰራችንን አገናኝተናል። ቮልቴጅ ዲቫይደራችን እዚህ ጋር አለ። እሱን እንትን ያደረግነው ቮልቴጅ ሴንሰራችን ለምን ሰርኪዩታችን ላይ አሉ። እነዚህ አናሎግ ኢንፑት ናቸው። ለምንድነው ዳይሬክትሊ ከዚህ ስናየው አሁን ለምሳሌ ኤኖት ኤዋን ከየት እንትን ያሉት ቀጥታ ከሴንሰራችን ላይ ከሶላር ፓኔላችን ላይ ወደ ሴንሰራችን መጥተው የተገናኙ ናቸው ማለት ነው። ለዛ እዚህ ጋር ምን ያደረግነው ማለት ነው? ቢቱዋችን ከሴንሰሩ ስለተገናኘ ከነሱ ደግሞ ምን እናደርጋለን ማለት ነው? ወደ አርዱናችን በእነዚህ በአናሎግ ኢንፑቶቻችን አማካኝነት ወደ አርዱናችን አገናኘን ማለት ነው። እነኚህ ሶስቱን ሁለቱ ሴንሰሮች እና የቮልቴጅ ዲቫይደራችንን ማለት ነው። እሺ እዚህ ጋርም ይሄኛውንም ይቺኛዋን ፓርትም ለብቻ እንትን ያደረግንበት አለ። ዲክሌር ያደረግንባቸው እያንዳንዱ ፖይንቶች ዲክሌር መደረግ ስላለባቸው ኦልሞስት እዚህ ኤክስፕሌን ለማድረግ ብዙ ኮድ ረጅም ስለሆነ ሌላኛው ፓርት እዚህ ጋር ሲስተማችን ምን አለው? ኦልሞስት ወደ 3 ስቴት ስላለው ስቴቶቹን የግድ ዲክሌር ማድረግ ስለሚገባ 3 ስቴቶቻችን እዚህ ጋር ዲክሌር አድርገናል ከነ ኮንዲሽናቸው ማለት ነው። የመጀመሪያው አይዲያል ስቴት ነው። ሁለተኛው ትራኪንግ ሶስተኛው ደግሞ ፎልታችን ነው። ይሄኛው አይዲያል ስቴት የምንለው ሲቹዌሽናችን ወይ ደግሞ ኔብል ላይ ሲሆን ሲቹዌሽናችን ትሩ ሲሆን ወይ ደግሞ ኖርማል የሆነ ስታተስ ሲኖር ምንድን ይሆናል ማለት ነው? አይዲያል ስቴት ላይ ይሆናል ዲስፕሌይ የሚሆንልን። ሁለተኛው ደግሞ ትራኪንግ የኛ ለምንድነው የምንፈልገው ማክሲመም ፓወር ስለሆነ ዋን ዲስፕሌይ የሚያደርግበት ጊዜ ምንድነው ትራኪንግ ይሆናል። ያንን ማለት ማክሲመም ፓወር ነው ትራክ የሚያደርግልን። የማንፈልገው ሲስተም ሲሆን ደግሞ ፎልት እንዲያሳየን ሁለት ዲስፕሌይ ሁለት እንትን ያደረግነው ማለት ነው። ሌሎችን ዲክሌር ያደረግናቸው ምንድን ናቸው? ከላይ የረሳኋቸው የአውትፑት ዲቫይደራችንን የመልቲፕላየራችን የኮንትሮል ሊሚታችን እነዚህም እዚህ ጋር ዲክሌር ያደረግናቸው ኮዶቻችን ናቸው። ስለዚህ እዚህ ጋር ምን አለ ማለት ነው? ለምሳሌ አሁን እዚህ ጋር ኮንትሮል ሊሚታችን ላይ ስናይ የስታተሱን ሪከርድ ያደርግልናል። ለምሳሌ ምንድነው የሚለው ቪ አውት ማክስ የሚሆነው 16 ቪ አውት 1 ሲሆን ቪፒ የፓኔሉ ሚኒመም 1 ሲሆን ከረንታችን የፓኔሉ 5 ምናምን ሲሆን እንደሚሆን እዚህ ጋር ኤክስፕሌን አድርገን ነው። ኦቨር ከረንት ትሪፕ አለ ቢሎው አለ። ስለዚህ አውትፑት ኦቨር ቮልቴጅ አለ። እነዚህን ዲክሌር አድርገናቸዋል ማለት ነው። እዚህ ጋር የዲዩቲ ሳይክላችን ያሉትን እዛ ላይ የተጠቀምናቸው እነዚህን ዲዩቲ ሳይክል ሚኒመም ማክሲመም ስቴፕ ሳይዙን እነዚህን እዚህ ጋር ዲክሌር አድርገናቸዋል። እዚህ ጋር ቅድም እንደገለጽኩት ስቴቱን ነው ኤክስፕሌን ያደረግነው። እዚህ ጋር ሶስት ስቴት አለው ኦልሞስት አይዲያል ትራኪንግ ፎልት ስቴት አለው። ምን ምን ሲሆን ነው የሚሆነው ስንለው ትሩ ኢኔብል ሲሆን ትሩ አውቶ ሞድ ሞስትሊ የተጠቀምነው እዛ ላይ ያስገባነው ሳይክላችን 50 ነው። ኮዶቻችንን ዲክሌር አድርገን ከጨረስን በኋላ ምንድነው የምናደርገው? እዚህ ውስጥ በመግባት ሄክስ ፋይላችንን እዚህ ጋር ሴቭ አድርገን ኦኬ እንለዋለን ማለት ነው። ሄክስ ፋይላችን እዚህ ጋር ሄክስ ፋይላችን አለ። ሄክስ ፋይላችንን ኦኬ ኦፕን እንለዋለን እናስገባለን። ከዛ ኦኬ ብለን እናደርጋለን ማለት ነው። ዲክሌር ካደረግን ከጨረስን በኋላ ኮዳችንን ከዛ በኋላ ምን እናደርጋለን? ወደ ረን ወደ ማድረጉ እንሄዳለን። ረን እናደርጋለን። ረን ስናደርግ የመጀመሪያ እዚህ ጋር ይሄኛው ይመጣልናል። ከዛ ሌላኛው ደግሞ ሌላኛው ግራፍ ዲስፕሌይ የሚሆንበት የዚህ አፕሊኬሽኑ ላይ ምን ይመጣልናል ማለት ነው? ግራፉ ይመጣልናል። ቀጣዩን ፓርት የኮዱን ቀጣይ ፓርት ማነው ይቀጥላል። አመሰግናለሁ።
የቀረውን ፓርት ሰማራይዝ ለማድረግ ሞክራለሁ ማለት ነው። የሚጀምረው ከዶክመንቱ ሲሆን ታይትላችን ዲዛይን ኤንድ ሲሙሌሽን ኦፍ አን ኤምፒፒቲ ሶላር ቻርጅ ኮንትሮለር that's actually for the efficient charging and to control charging system to harvest energy from solar plants or even it's well widely divide green energy to use nowadays that's not pollution exposed or it's green and pure energy. Nowadays, there are the systems which we used to harvest the solar energy. Yeah, obviously there are most common known two systems, which is MPPT and PMW charge controllers. The most efficient method is an MPPT solar charge control systems, which is controlled with closed loop both current and voltage sensing with real times. So I wanted to express the our our titles that there is abstract here as our instructors given that this mini project presents the design, firmware's development, and simulation of the microcontroller based maximum power point tracking solar charge control system that the systems draws the power from photovoltaic panels with nominal maximum power of about 80 voltage, and the condition is which through switch to DC states charges about 12-volt batteries continuously operating the panel. Its observation PO tracking algorithm. That means PV is currently measured within a 169 analog current sensors, and the voltage is measured through potential divider, which is two resistors is connected in series. That's fed to the analog input of Arduino. This measures with B225 resistor voltage sensor modules. The, the output voltage is measured with resistor dividers. TCP 4420 gate driver IC is used to drive the MOSFET gate, which is to drive the gate of MOSFET for fast switching. That means if we do the gate directly to the if we hook up directly the MOSFET gate to the Arduino, that can't directly drive it because of the MOSFET need more voltage to be driven. So to do that efficiently to be drive, we feed the pulse from microcontroller to the dedicated gate driver. Then we use the driver output to drive the MOSFET as well as to control large range of duty cycle in order to compensate the system up and down or low or highness of the voltage or the power of the PV panel generates. So the main objective is this MPPT controller is to harvest essentially power from the solar panel. So uh, as I tried to mention on the title, the maximum PowerPoint tracking system is used for the to track the maximum PowerPoint which is generated by PV or solar panel. Somehow I can explain something about the documents, the theoretical background. Here is the solar voltaic systems, photovoltaic cell converters inside the sunlight to change sunlight into electrical energy. That cells are connected in series to form the modules usable. So to track the maximum power point, there is IV and PV curves. Here is expressed on the graph. DC to DC converter, charge controller, circuit diagrams like this. That's even on protest models, we visualize all of the parts of our systems. This is the graph which generated from our Python dashboard. So uh, the hardware designs or power stage maybe here is the sensing part, the voltage dividers, so on. Even also there is a per tab observed or MPPT algorithm with the protection logics. If we start there is flow charts with initializing systems, set LCD, duty cycles, set per tab, step duty cycles, read initial voltage and currents, then it multiplied by voltage and current gives power. Then the algorithms mm, real-time tracking with the powers. If the power is low, then it may it it may be adjusted with closed loop systems to compensate the system outputs to keep on the maximum points. Even the overall system is here. The first, if you see here, there is a solar panel that's fed into the MPPT control circuits. Then MPPT circuit, here is the MOSFET from there, which divided by dedicated TC 4420 driver ICs, which get the pulse or the duty cycle drives from the microcontroller. Here is analog analysis of the systems, COM port, Arduino microcontroller, LCD display, the potential divider or voltage divider circuit that's used to measure our battery's voltage, and INA 169 analog circuit DC current sensor. To summarize this document, even we prepare some of the rough documents, maybe, but it's enough to cover or summarize our system. So let I pass to the our practice model, which is like this, as the title tells. MEPPT solar charge controller. Author is Defense University Engineering College, Instrumentation and Control Team 2. So the system fully described on the documents. If you see here, it's like MPPT totally. So let us see our Python dashboard. There is the codes which is used to uh, display our system in remotely or teletracking systems, which is we used Python to do that. There are libraries here. If the import system time CV, those are the libraries. From those library, we take or collect, import, DQ are the from system libraries. All of those lines are libraries. We used PyQt graph as PGEs. We used to sketch the graph in our dashboards. There are states here. There are 3 or 4 states. Idle state, maximum power point tracking state, fault state, manual state. They have the different meanings. Idle is if the solar panel is generating constant voltage or normal sunlight condition, which stay at idle condition. If the solar panel generating low voltage or which is not insufficient to charge the battery, it track maximum point or it try to compensate our system to generate the maximum and stable power. Fourth state is if the system if the solar panel lower than or greater than or high voltage, then it indicates that it's fault generating. Then our system may be, if in a fault mode, the output deactivated, it keeps the system failure. Manual mode is the mode which is controlled by manual or human interface. The There are several codes here, maybe with the insufficient or with the shortage of time. I pass it by showing some part by part. It's well indented in the VS Code. Yeah, it's interactive. So this class is this part is main window or the UI parts. The UI parts. So finally, it's like the code's like this. It's about around 301 for line, and we run it. If we run it, we get our dashboard, which is very interactive in black background. I like it. We run the code, we get our dashboard. It's clear and black background. Then we connect to the our virtual Once it's connected with the COM port, and I pair the port in the virtual driver, port 6 and 3 pair. So yeah, once it's paired, then I pass to the our dashboard. So we connect here, COM, we select port from our dashboard, COM6. Then our pin rate is 9600, it's correct. Then I connect. Boom, it's our system is working. So there are the user interface in our system. Those systems are charge enabled mode. There are two modes to operate manually. The manual mode take the user interface or uh, HMI interface to adjust our duty cycle. If it's ma- automatical, no need to control manually of duty cycle. So it's reading the our model from protest. So if we see our dashboard and the reading, it's the same reading. So uh, real-time readings, and even it has telemetry reading system. If you interface the wireless communication system, it really reads this system. So we can fully track, fully control, fully see our fault, analyze the and telemetry system with our solar plant or solar system. So it's best and preferable way to control our solar plant with this dashboard. If you see something, there are the ways or the user interface system. It's good UI with a black background. It is sketch real-time graphs. If you see here, the output is fluctuating. Our PV output is fluctuating. Then the MPPT output is straight. So we get that the point we assign or we are doing to. So our output is very stable, then the PV is fluctuating. So our goal is to give the maximum point tracked by the system. So to summarize, the our project it's essential and the one of modern project to control the solar plant efficiently to harvest the energy with modern way, telemetry control system, and most efficient the battery charging, even it control with closed loop system with real-time tracking, indicating uh, fault and other HMI systems. So if we see the our firmware or Arduino code, there are there is a code MPPT charge controller with Protest analog ADU engineering instrumentation. That's our comments or our the signing of our assets. So if we start from the included liquid crystal, this is a library of LCD display. We assigned it to reset with 12 pin, enable with pin 11, D10 with D4, D9 with D5, D8 with D6. So even there is the pin assignment of the our hardware systems like this. So if you see on our protest, the LCD wiring is like this. The same to on the code, we assign the each wiring with the same term, the same as in our code. So there are declaration. This is a calibration declaration or analog to digital conversion reference. We uh, we declared as the constant float. So then the next is our the voltage reading modules. Even if you see the our models on protest, there are the sensors which we used to read current and voltage. We used analog INA 169 analog current sensor for current, and we used potential divider for the voltage reading both for battery from the PV cell. Then as we go to our code, or even everything of the wiring, including wiring algorithms and doing setup is included in the code. Those above codes are even declaration. Those codes are declared. Those codes are declared. So there are the states, as I tried to mention on our dashboard or a telemetry dashboard of Python machine. So there are states. Idle state. Idle state is 0. Tracking state is 1. The fault state is 2. The manual state is 0 as I defined on the code. The state ideally equal to the bool or boolean uh, enable to automate something that does the giving the command with the code. There are our code sections and reading sections. We all the sensor inputs are analog that converted in the microcontroller or microcontroller boards of Arduino with built-in ADC converters that handled with this code. Uh, Even control loops, we used closed control loops to control our system where is voltage real time where which point is our voltage is tracking, even to constrain the voltage at the maximum point. We use all the sensors which are INA 169 analog sensor and potential dividers, which feeds the data to the analog sensor of Arduino. Uh, there are those codes are LCD installation codes, which install LCD to print our strings, some readings. Thanks a lot to follow me. My name is Manai I'm the fourth year electronics engineering student. Thanks for